All right. So we on lesson 8. We're dealing with the what power function.
What?
The what power function. So the way I read it is
What page is that?
not a clue. So the way I read it is, let's see, so I got what power 2, 8 equals 3. So the way I read it is what power of 2 is 8. So what power of 2 is 8? So if I'm thinking about that like an exponent, I don't know what this number is. But so what power of 2 equals 8? Can anybody tell me what that is? Spoiler alert, it's already up there. 3. 2 to the third power is 8. Yeah, that doesn't make sense. That's 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. That's what exponents do. So, like I said, the way you would think about this is what power of 2 is 8? And the answer is 3. And in the next one, what power of 3 is 9? The answer is 2. So then let's do the next one. What power of 6 is 36? It's 2. 6 times 6 is 36. Excellent. What power of 2 is 32? Okay. So we know 2 times 2 times 2 is 8. So we put another 2 to make it 4. That's 8 times 2, that's 16. We put another 2. That's like 4 times 8. 4 times 8 is 32. So it's 5. 1, 2, 3, 4, 5. I'm waiting. 2 to the 5th power. Move up.
That's 32, right?
Yeah. 2 times 2 times 2 times 2 times 2. That gives us 32. So what about what power of 10 equals 1,000? 3. How did you get 3? It's 10 times 10 times 10, or another way to think about it is you could just count the zeros on your answer. It's 3 zeros, so I got 3 10s going on. So that's 3. So what power of 10 equals 1,000,000? So how many zeros? 6. So that's 6. Well, now they're about to throw you for a loop. Let's see if you get caught. What power of 100 is 1,000,000? Okay. How many zeros do I got? I got 6 zeros. How many zeros I'm starting with? 2. So how many times do I have to put 2 zeros together to get to 6? 3. 100 times 100 is 4 zeros because it's 4. So I got 10 grand. So if I multiply 10 grand times 100 again, that's what gives me the million. That gives me 6 zeros. That's 100 to the third power. What power of 4 equals 64? 3. 4 times 4 times 4 is 64. Skipping that one. What power of 9 equals 3? So I got a higher number that's going to a lower number, but I'm taking it to a power. We talked about this stuff yesterday and the day before then. What's my exponent? 1.5. This one. Say it again. That's close, but that's not it. Negative exponents change your position. We're not changing position. We're just going from a higher number to a lower number. Every time we used an exponent, the number went up, except this time. What was the time? We were doing it yesterday and the day before. Say it again, ma'am. Yep. So, what power of 9 equals 3? Not 1/3. It's 1/2. 9 to the 1/2 power. Yeah, but remember, we're going the other way. I'm taking 9 and taking it to a power, and we're ending up with 3. So how did that work? Well, if I take 9 to the 1/2 power, that is the same as the square root of 9 to the first power. Because yesterday and the day before, we were talking about fractional exponents or rational exponents. So what does that equal? That equals a radical with the index of b and x to the power of a. That's what we did. So if I have 9 to the 1/2 power, that's what that means. And the square root of 9 is 3. So it's 1/2. It's what we were doing yesterday and the day before.
What page we do yesterday? 27?
I don't know off the top of my head, sorry.
Oh, we doing it.
Yeah, we did that yesterday and the day before. So anyway, what power of 5 is the square root of 5?
What is that?
It's 1/2. Excellent. Don't make it harder than it is.
All of them is
5 to, no, not all of them. 5 to the 1/2 power equals the square root of 5. Because, see, 9, you can actually take the square root of 9 and get a number. 5, you can't, so you just leave it like that. So my next one, I got 1/2. What power of 1/2 equals 1/8? No, it's not 1/4. It's not 1 over anything. It's not 4. It's not 2. It's 3. So there's a rule that I wrote up there that says if you have a fraction, right, that's taken to a power. Okay, let me change that because I don't want to be confusing. Nope, that's not it. That's scientific notation. This isn't scientific notation. So if I have a fraction and I take it to an exponent, I can look at that separately. So I got x to the a over y to the a. So I can do that with this. 1 to some power equals 1. It doesn't matter what power I do. Doesn't matter at all. Right? So, but 2 to what power gives me 8? 2, as we said earlier, to the third power equals 8. So if I'm looking at this fraction and I can separate them, I think of what power do I take 2, or what power of 2 will give me 8 on the bottom, because the 2's already on the bottom. I don't got to change positions or anything. So that's going to be 3. It's just straight up 3. Because 1/2 to the third power equals 1 to the third power over 2 to the third power. 1 to the third power is 1/3. 2 to the third power is 8. What power of 42 equals 1? 0. Because anything to the 0 power is 1. Now this one's tricky. What power of 100 equals 0.01? I know. It's tricky. Anybody got any ideas? That's actually right. So let's talk about why. If I take 0.01, if I take 0.01 and I think about what does that mean? Think about money. What does that mean in money?
Because it was like you said said after 0 it's gonna be 0.
Yeah.
I thought what's behind 0 is -1.
That's fine. I'm gonna ask you again. 0.01. What is that in money?
1 cent.
1 cent. And how many cents does it take to make a dollar? 100. So that is 1 over 100. 100 divided into 1 is 0.01. So what power of 100 will give me 1 over 100? -1. Because negatives change the position. So that's a -1. The exponent rule says if I have x to the negative a power, it is the same as 1 over x to the positive a power. The negative exponent, when I change it positive, it changes my location. The negative doesn't change the sign of my stuff. It just moves it either up or down. So now, what power of 2 gives me 1 over 4? That's part of it. That's not it.
2.
That's part of it.
Do you do what you did for 3?
2.5.
Definitely not 2.5, and it's not 1/2 either, because technically my number goes up. It goes from 2 to 4.
2.
So 1/6.
Hmm?
1/6.
1/8.
What does a negative exponent do? Change location. Where's the 2 at right now? It's the base or it's up top, right? It needs to go to the basement, so I need a negative exponent. So that'll kick it down, and then to the second power will make that 4. Does everybody understand what I'm talking about? That's
This one not going.
These are my exponent rules. Product rule, quotient rule, power of a power rule, power of a product rule, power of a quotient rule, zero power rule, negative exponent rule. If I have something that is a negative exponent, if I want to make that a positive exponent, I change its location. So a negative exponent becomes a positive exponent when I change its location. If I got 2 to the negative 2 power, 2 to the negative 2 power is 1 over 2 to the second power, which is 1 over 4, which is what we got. The negative changes my position, and then I apply the power. The negative doesn't give me a sign. All it does is change my position. Questions? Yo,
Can you explain this one?
explain what? What I just said? No problem. I mean, again, it's no problem.
Explain the part where, because I understand it, but you know how you said it turns to 1/4?
Yep.
Basically just turn the negative into a positive 2.
No.
What?
Well, okay. I take that back. Let me not say that.
Turn,
When I'm taking a negative exponent, it's 2 to the negative second power. Right there, that negative, if I want it to be positive, I need to change this location. Right now it's up top. If I make it positive, it's 1 over 2 to the second power. So now it's in the denominator. Now it's just 2 to the second power. What's that?
4.
That's 4. So 1 over 4.
Right.
Okay.
So the negative exponent puts it down there, and then the 2 makes it a 4.
Can you change the position?
Right, changing its position.
Can we get that paper?
Sure, why not? It's the same thing on page 5.
It is?
Yeah.
No, it's not.
Okay, it's not.
Well, first, it don't, always not like yours.
Okay.
You want
They're not like us either. So anyway, the last one.
to show you that.
You don't have to show me. I know exactly what you're talking about. Okay, I don't. I totally don't.
Yours got the label on the side of it. Ours
Yes,
don't.
I know. I know what you're saying.
That's what I was looking for.
Okay. I'm saying the label to me don't make that much difference, but it's fine.
The answer was 1 over 4, right?
The answer was -2. Yo, be my guest. It's not Fat Hat. So my last one, you know, if it's okay, I'd just like to finish up, if that's all right. You know, I mean, I know y'all got important stuff to talk about, and it's not like I'm recording. Oh, wait, I am. Is it okay if I continue?
Yes.
Excellent. So the last one, I got 1/4. What power of 1/4 is going to equal 2? That's part of it. I definitely got a negative because I need to change positions. I need to go from the denominator to the numerator. It's not -3. It's -1/2. Oops. Yep. Why is it 1/2? Because we're starting with 4 and we're going down to 2. So 1/4 to the -1/2. The negative switches my position. So now it's 4/1 to the 1/2 power. The 1 just falls off because 4 divided by 1 is 4. So that's 4 to the 1/2 power. And what did we just say the 1/2 power is? It's every time I put my pen there, it blocks it. The last rule says fractional exponent rule. That's not something that's on your on page 5, I believe. So this right here becomes the square root of 4 to the first power, which is 2. The square root of 4 to the first power is 2. So that's going to be -1/2. So, do we got any questions? I have 1/4. That is a fraction. The 1 is kind of inconsequential. The 4 is what we're looking at. So the 4 is where? It's the basement. It's on the bottom. What is my answer? My answer is not on the bottom. So if I have something that starts out a fraction and ends up a whole number, that's a clue that I need to change position so my exponent is negative. The opposite goes the same way. If I start with a whole number and I end up with a fraction, that probably means that my exponent is negative because I'm changing positions. So it's negative. When I look at the number, the 1 is kind of inconsequential. What's not inconsequential is the 4. And inconsequential means it don't matter. So that 4 matters. I need to do something to 4 to make it change position and then give me a 2. So it's going down. What do I do to my exponent if it's going down? If it's going down, I do what? I need a fractional exponent because that's the square root of 4. How do I write the square root as exponents? That's 4 to the 1/2. But my 4 is on the bottom. I need to change position, so it's going to be the -1/2. Negative changes of position. Fractions make your numbers smaller. So you're taking it to a power, but because it's a fraction, it's making your number smaller. Does that make sense? Because the exponent is a fraction, yes, it went from 4 to 2. The fact that it's 1/4, because that's a 1, that lets me know that I only need to focus on the 4.
Not like that.
Then like what?
I said, when you leave for your 4-day thing, can you leave for good work
Yeah. I was planning on having a makeup day Friday. So, let's see. I got a couple more minutes. So, no, it's -1/2. See, what power of 1/4, so there's an exponent that goes right here, equals 2. This is my answer to the problem, is what number goes there. But technically, if I'm talking about, that's not us, if I'm talking about the power, right, that's the number that goes there, and then you could say that that's kind of my answer, but that's not, that's what the function is telling us. 1/4 to some power equals 2. All right, and the power ends up being -1/2, and so that's my answer. So,
The big numbers on here?
what?
The big numbers.
What about it? I don't understand.
You do the big numbers.
Like what? Okay. What power of 7 equals 49? 2. 2 to the second power is 49. What power of 0 equals 7?
Oh, 7?
Nothing. Or not applicable. Or don't work, Ferg. You could put any of those answers. Because you can't take 0 to some power and get a number that's not 0. It's not going to work. Couldn't hear you, sir.
0 can't go into anything.
Well, yeah, but don't think of it like, well, I guess you could think of it like that. Yeah, 0 can't divide into 7, so yeah. So there's nothing. What about what power of 5 equals 1? 0. Anything to the 0 power is 1. Well, what power of 1 equals 5? What power of 1 equals 5? Nothing.
Oh, it's the same because
Because 1 to any power is still 1. You're never going to get another number besides 1 when you take 1 to a power. All right? Don't work, Ferg. You can put any of those. So now, what power of -2 equals positive 16? Positive 4. Because when my exponent's even and I start with a negative number, the negatives cancel off. So what power of -2 equals 32? Nothing. Can't do it. Because I'm starting with the negative number. 2 to the 5th power equals 32. Is 5 even? No, it's not. So if I start with the negative, I'm going to end with the negative if my exponent is odd. So that don't work. So that don't work, Ferg. So we got time for maybe 2 more. What power of 1/3? Come on, man. Got stuff to do. 1/3 equals 9. It's definitely a 2. It's -2 because I started with a fraction. I ended with a whole number. So the negative is going to change my position, and the 2 is going to take 3 to 9. What power of -1/3 is 27? Not 9. That's 9 times 3. We're doing powers. Say that again. It's a negative number. That's a positive number. If I need to go to the 3rd power to make that happen, the negative's going to be there because it's an odd number. So nothing. Not applicable or don't work, Ferg. Now, before you get up, have a seat. Have a seat. Does everybody see what example 1 says? Where's what the power at? It ain't there because this is what's going on. We said what power of b is x. That's actually what a logarithm does. A logarithm. And so that's what we were practicing, even though we were calling it something else. So log of base 2, or excuse me, log base 2 of 8. That's how you say that. You say log base 2 of 8. And guess what that equals? 3. Because it does the same thing that we just did with this what the power stuff. Only instead of saying what power of this equals whatever, the base is that number. That's why we called it a B for base. All right. This is going to be one of the videos that I continue for tomorrow.